All right, so listeners are probably here because they want to get serious about code security, right? And I think a lot of people get tripped up on the difference between code level and plan level scanning. And that's what we're diving deep into today. We're going to look at some pretty surprising stuff about how vulnerabilities can sneak in, and also the tools that can help us catch them.
Yeah, it really is amazing how much our industry relies on code these days. But traditional security approaches, they're kind of falling short, you know what I mean?
In what way?
Well, they tend to focus on the final product,
Yeah.
the end result, right? And that leaves all these gaps in the development process where these risks can just hide.
I see, I see. Yeah, that makes sense. I mean, especially when you consider how complex software has become. So where does code level scanning fit into all this?
Well, code level scanning is really about bringing security right into the development environment itself. So you have tools like Checkov, right? And they look at the actual raw code. They're looking for patterns that might be a sign of some vulnerabilities. So it's a powerful first line of defense, you know?
So it's almost like having a security expert looking over the shoulder of every single developer, like catching these potential problems before they even make it into the main code base.
Yes, that's the idea. And the beauty of these tools, they can detect a lot of these common issues. Things like hard-coded credentials or insecure configurations, things like that. In fact, one of the sources we were looking at talked about Checkov detecting this firewall rule that leaves port 22 wide open to the entire internet.
Oh, port 22, that's the one for SSH, right?
Yeah.
Which basically gives you direct access to the server.
Right.
So leaving that open to everyone is basically like leaving the front door of your house unlocked with a big sign that says, "Welcome, hackers."
Exactly. Exposing those, critical services like that. That can have just disastrous consequences.
Yeah.
Attackers could get unauthorized access, right? They could steal all your sensitive data or even worse, take control of your entire infrastructure. So catching these errors early is really crucial.
Right. Okay, so code level scanning seems like a no-brainer, right? It's fast, it's easy to integrate, it catches these obvious security flaws. But, I have a feeling there's more to this story, right?
Yeah, you're right to be a little skeptical. While code level scanning is really valuable, it does have some limitations.
Okay.
It only sees what's explicitly written in the code itself. Not how that code might actually behave when it's running.
Wait, hold on. How is that even possible? If the code looks secure, shouldn't it be secure when it runs?
Not necessarily. Think about it this way. Code often uses variables, right? And those are basically placeholders for values that are only determined when the code is actually running at runtime. So a code level scan might see that there's a variable being used in a really security sensitive context, right?
Right.
But it won't know the actual value of that variable until the code's actually executed.
Okay. I think I see where you're going with this. So you could have code that looks totally fine, passes the code level scan with flying colors,
Right.
but then turns into a major security risk when it's actually running because of what happens to those variables.
Exactly. And the source material actually gives a perfect example of how this can happen. So let's say a developer's, defining a firewall rule. It's supposed to restrict access to a very specific range of IP addresses.
Right.
But instead of, like hard coding that IP range right there in the code, they decide to use a variable.
Okay, so far so good.
Yeah.
I mean, using variables is good coding practice, isn't it?
Absolutely.
Yeah.
It is. But here's where things can go wrong. If the value of that variable isn't defined properly, right? Or if it's, accidentally set to a value that's way too permissive, you could end up with this firewall rule that's basically allowing access from anywhere. And a code level scan, it wouldn't catch that because it's only looking at the code itself, not the values of those variables when the code is actually running.
Wow. That's a pretty sneaky way for a vulnerability to just slip through the cracks. It's like a ticking time bomb just waiting to explode.
Exactly. And that is exactly where the need for plan level scanning becomes crystal clear.
Okay, I'm officially intrigued. Tell me more about this plan level scanning superhero. How does it solve this variable problem?
So plan level scanning, it kind of takes security analysis like a step further, right?
Okay.
It examines what we call the execution plan of your code. So in tools like Terraform, This plan basically lays out exactly what's going to happen when you deploy your code, like which resources are going to be created, which ones are going to be modified or deleted, and this is the important part, it shows what the final values of all those variables are going to be.
So it's like having this crystal ball that shows you exactly what your code will do before you actually, unleash it upon the world.
Yeah, that's a great way to put it. And with that level of insight, plan level scanning can catch vulnerabilities that code level scanning would just completely miss.
So going back to our firewall example, would plan level scanning actually be able to see that the variable is set to like an unsafe value, even if that value isn't explicitly defined in the code itself?
Yeah, absolutely. When Checkov analyzes the plan, right, it
Mhm.
sees the whole picture. It sees everything, including the final values of all the variables. So if that firewall variable ends up pointing to 0.0.0, like we talked about, allowing access from anywhere, Checkov would flag that as a critical security risk.
That's impressive. It really seems like plan level scanning just adds a whole new dimension to code security.
Yeah.
But I'm curious, what else can it do besides catching these kind of sneaky variable related issues?
Yeah, it's not just about variables, right? Plan level scanning can also enforce more complex security policies, ones that kind of take into account like the relationships between different resources.
Okay.
So for example, let's say your organization has this strict policy that all cloud storage buckets have to be encrypted, right?
Right.
Now a code level scan that might confirm that yeah, the code includes encryption settings, it's in there somewhere. But a plan level scan, it can actually verify that those settings are actually being applied correctly when the bucket is created. It's actually doing what it's supposed to be doing.
I see. I see. So it's like making sure that all the pieces of the puzzle fit together securely, not just that each individual piece, looks okay on its own.
Exactly. And this is especially important in these complex cloud environments, where you might have hundreds or even thousands of resources that are all interacting with each other.
Oh,
So
no.
plan level scanning really helps ensure that the entire system, not just, isolated components, that the whole thing actually meets your security standards.
Okay, this is all starting to make a lot more sense. But I got to admit, I'm still kind of wrapping my head around this idea of a plan. It sounds kind of abstract,
Yeah.
Can you give me a more concrete example? Like what does the plan actually look like, and how does Chekhov actually use it?
Yeah, of course.
Yeah.
So think of a Terraform plan as like a blueprint,
Yeah.
right? It outlines all the actions that Terraform's going to take to get your infrastructure into like the desired state that you want it to be in.
Mhm.
And this blueprint, it includes details about, the resources that'll be created, their configurations, any dependencies between them. It's really a comprehensive view of what's about to happen in your cloud environment.
So it's like Terraform saying, "Hey, here's my plan, right?
Mhm.
I'm going to create this virtual machine with these specs. I'm going to connect it to this network, and then I'm going to store its data in this storage bucket over here." And then Chekhov is like right there, looking over its shoulder, saying, "Hold on a second. Let me double check that all of that actually meets the security requirements."
Yeah, that's a great analogy. So Checkov basically it parses this plan, right? It extracts all the relevant information about the resources, the configurations, the relationships between them, all of that. And then it compares all of that information against its library of security policies.
And those policies can be customized, right? We talked about that earlier.
Exactly. And that's where things get really interesting. You can go beyond just the built-in policies that Checkov provides, and you can actually create your own custom policies that are really tailored to your organization's specific security needs.
Okay, let's talk more about these customer policies. What kind of things can you actually do with them, and
Yeah.
and how difficult are they to create? Custom policies, it sounds like they're really the key to like locking down security in a way that's specific to what an organization actually needs.
Yeah.
It's like having a security system that's been tailor made for your house.
Yeah.
Instead of just relying on like a generic, alarm system, one size fits all kind of thing.
Yeah, that's a great analogy. And the beauty of custom policies in Checkov is that, they can be as simple or as complex as you need them to be. Like you can start with some really basic checks, right? Like like making sure that all resources have specific tags, for tracking and inventory purposes, things like that. And then you can gradually kind of, build up to more sophisticated policies that enforce these really granular security rules.
I'm already thinking about all sorts of possibilities here. Like you could create policies that would prevent developers from, accidentally exposing sensitive data to the public internet,
Right.
or policies that would enforce specific compliance requirements based on, industry regulations, things like that.
Yeah, exactly. And the process of actually creating these policies, it's surprisingly straightforward.
Okay.
Checkov uses this really simple but powerful syntax that lets you define the conditions that you want to check for in the Terraform plan. So you can use, logical operators, you can use regular expressions, you can even reference external data sources
Wow.
to create these really, really specific and targeted policies.
So it's not just about looking for obvious errors anymore, like open ports and things like that. You can create policies that actually reflect the nuances of your organization's security posture and their risk tolerance.
Exactly. And that level of customization, that's what makes plan level scanning so powerful, right?
Okay.
It goes beyond just, catching common vulnerabilities. It actually empowers you to proactively enforce the security standards that are the most critical for your business.
I imagine this also makes life a lot easier for security teams.
Yeah.
Because instead of, manually reviewing every single line of code and every single configuration setting, they can basically rely on Checkov to just automatically enforce those policies at scale.
Yeah, absolutely. And that frees up security teams to focus on more strategic initiatives, right? Things like threat modeling and vulnerability research instead of getting bogged down in these really tedious manual reviews. So it's really a win-win for everyone involved.
This has been such an eye-opening deep dive. I feel like I've gained a whole new understanding of how code scanning can really help organizations build more secure and more resilient systems.
Yeah, I'm glad to hear that. And I think it's important to emphasize that this is not just about, tools and technologies.
Yeah.
It's really about fostering this culture of security awareness and collaboration throughout the entire development lifecycle.
Yeah, that's a really great point. I mean, tools like Checkov, they can automate a lot of the heavy lifting, right?
Right.
But it's ultimately up to people to really understand and apply those security principles in their everyday work.
Absolutely. Developers, security teams, operations folks, everyone needs to be working together to make sure that security is baked into every single stage of the process.
So for our listener who's now really eager to implement these practices in their own organization, what would be the best way to get started?
I'd recommend starting with the basics, get familiar with the core concepts of code level and plan level scanning, explore the built-in policies that Checkov provides, and then, start experimenting with creating your own custom policies. There's tons of resources available online, including Checkov documentation and their community forums.
And as you gain experience, you can gradually expand your policy library and integrate Checkov more deeply into your development workflows. It's a journey, not a destination. Yeah.
Sure. Well said. And I think the most important takeaway here is that security. It's not a one-time event.
Mm-hmm.
It's an ongoing process of continuous improvement. So by embracing tools like Checkov and fostering that culture of security awareness, organizations can really stay ahead of the curve. They can build systems that are both innovative and secure.
That's a fantastic note to end on. Thank you so much for joining me on this deep dive. It's been a real pleasure exploring the world of code scanning with you.
Well, thank you for having me. It's always exciting to talk about, the intersection of security and innovation.
And for our listener, we hope this deep dive has given you the knowledge and the inspiration to really level up your own security game. Remember, a secure future starts with secure code.